I'm excited to be here with Encino Environmental Services. And we got Joe Etheridge and Taylor Henningen here. Joe, I'd love to hand it over to you to tell us a little bit about the oil field.
No, I was going to lead in with my oil field joke.
That's the joke, yeah.
Yeah. So, Roughneck walks into a hardware store and asks for a wrench. The attendant asks him, "Well, what kind?" He says, "Doesn't matter. I'm gonna use it for a hammer anyway." No.
Yes, that's about right.
Yeah.
Yeah, that's good.
Oh, that's good. That's good. So, no, tell us about Emissions Impossible and what we're discussing here today.
Yeah, sure. So, well, thanks for having us.
Yeah, no doubt. Thanks for having us.
Yeah, appreciate it. Mission Impossible. I mean, basically, what we're just describing is an emissions management or measurement ecosystem using various types of signals and nodes and instruments from the environment and the physical world in order to tell a story or contextualize your operations. And that's really critical for emissions. And so we're here today to kind of talk about the different types of monitoring options there are, and kind of what the hierarchy of those are, and what each level can bring to your operations.
And this is increasingly important today, not just because of the way we talk about energy and climate, but just the opportunities coming from incentives, right?
Sure.
And tell us a little bit about that from customers.
Yeah. I mean, there's different. It's becoming a wild space. You know, it's a new space, right? And so, as far as monetary incentives, you've got the IRA bill that's coming down with different regulations and incentivizing, the operators. You've got carbon credits that, folks are looking to capitalize on. And, it's baselining operations today and, doing a balance and a check, kind of in the future and seeing where you're at and where, operators not only can keep, possibly, get incentives that way, but keeping the product in the pipe.
Yeah.
Right. I mean, that's a huge incentive, is hanging on to it. So not just being a good steward environmentally, but, hanging on to your product.
Yeah.
And you also have some international initiatives that are in play as well. There's the Oil and Gas Methane Partnership 2.0, OGMP 2.0, which is kind of a global type standard. And I think that's the future. I mean, we're seeing the entire world kind of shift towards this ascribing environmental attributes to products and investment strategies.
So. Yeah. To that point, OGMP 2.0, we're not only seeing it here domestically, but we're getting, RFQs and tenders brought in from Oman recently, Europe, and other countries over there. So
interesting. So not just Europe, not just US, but really global.
Yeah, no doubt.
Interesting. And tell us, have you seen a real shift in the last few years, or has this been a growing trend? Like, what's really kind of picked up the interest in your mind?
I think that what kicked this all off was the mandatory greenhouse gas reporting regulations that came out over 10 years ago during the Obama administration. I think that's what sort of started it, because now all of a sudden the regulators are getting all of this data that's voluntarily, you have to report. There's no fees or fines associated with any sort of overages. But if you have to consider that the government now has 10 years worth of this data filtering in, the challenge with that data is that in the absence of any sort of measurements or runtime hours or things like that, there's default factors and default runtime hours that are to be used, and that could inflate the values or the representations, or in some cases they could actually be a misrepresentation excuse me, of the operations. But the fact of the matter is it's very difficult to tell. And so now I think that's pushed the industry into the realm of measurement, actually recording these observations, ascribing various types of contextualization attributes to it. Blockchain is now being used in this space as well. So I think that's what kicked it off. And then people, as the generations cycle through, certain things are more important to certain generations than others. So.
Yeah. And it's important that there was a reporting. Now we're getting to this environment where we're measuring, and when we're measuring, we're going to manage, and that's what's changing everything. And so part of the reason we're here today is we have a presentation we want to go through. Do you want to cue that up and we can start walking through it?
Sure.
Yeah. All right. All right. We'll hand it over to you, I guess, Taylor.
Yeah, so I mean, some of the topics here: greenhouse gas emissions measurement within the industry. What are the options? Of course, we talk about data, and not just the data, but what do you do with that data? You could collect all the data in the world, but unless you're, as we talked about earlier, going through that and really pulling out the attributes or the signals that are really valuable, and not just collecting data just for the sake of collecting data. Post-processing can be a challenge. As we talked about earlier, kind of the idea is like shifting the attitude towards kind of a holistic view of your system, and you can do that through a vertically integrated type measurement ecosystem, and we can talk about that here in a minute. But leveraging modern measurement and analysis, I mean, that's critical. Technology changes, advances. I mean, in the case of like short span of 6 months, I mean, for example, the satellites that are being put up today are already obsolete. There's already technology coming down the line in future launches that have better resolution and better qualities, and so that's another thing. I mean, technology is advancing, and I think it's prudent for everybody to embrace that and to invest in it as much as possible. As we mentioned, we talked earlier before the show, the sort of logic that underpins this is system dynamics, principles of systems. It's a well-known discipline. Science is well-known. It was pioneered by a man by the name of J.W. Forrester, and he is the architect of the synchronization of the early warning detection systems that was used during the Cold War, and it was very effective. He went on to teach at MIT and teach on the principles of systems. And his name was brought up when I was in college taking ecology, because biologists were starting to look at ecosystems mathematically, looking at these signals and being able to predict and determine. Same principle in oil and gas, except you have a billion data points as opposed to just some smaller defined data points. You have all these different signals that you're trying to process. So I think that as part of any measurement ecosystem or any plan that you're developing within your company, you have to have some sound logic or science behind it as the way you manage that data and the way you take action. Yeah. So that's what's also important in the whole concept of a feedback system.
Yeah, and I want to preface for the audience, if you guys have questions in the system, we'll see them and try to ask them throughout. So feel free if something perks your ears. I'm happy to have that asked here. When we think about these complex systems, I think sometimes it's challenging for people to understand that we really got to dig in and see what's going on, and that's why the systems modeling is so important.
That's right.
And especially in the context of how does a little methane here affect things? How does NOx over there affect items? And ultimately that ends up in how we think about regulation. But the modeling allows us to also be very efficient in where we deploy our fixes, right? It's not just about meeting a minimum regulatory requirement. It's about saying, how can I affect my most efficient input here to create kind of the outsized, outcome.
And that is one of the critical elements of system dynamics is modeling. Okay. And as we talked about earlier, is you could take a facility and put instrumentation all over it. And you can get this very high resolution understanding of emissions characteristics, but what do you compare that to? What is good? Is that good or is it bad? You don't really know. And so modeling provides you with the ability to use conservation of mass, conservation of energy, thermodynamics to say, okay, based upon these material properties, should this system behave?
Mm-hmm.
And then any sort of measurement beyond that, you can measure your performance relative to that baseline. And that's very important.
Mm-hmm. Mm-hmm.
Yeah, and I think that pushes like the technology boom that we're seeing with monitoring, with continuous monitoring, to meet those objectives for modeling all the different various inputs, because I think it's been stated numerous times I've heard before, there's no silver bullet, right? So there's, ground level truth to, monitoring and scanning from the sky. So I think it all goes to that.
And we'll talk about it in the next slide or the upcoming slides. There is no eye of providence. There's not one thing that's going to tell you everything that you need to know about a system. And so it's really important to look at the signals that you have available to you, number one, first foremost, using what you have, and then supplementing that with various types of measurement technology that can help enhance those signals and then provide you a better output.
Yeah, and that goes back to, Joe, what you were saying before. It's important to stay on the front end of the technology curve, because you get new signals, you get new granularity, and that gives you a better insight to what's going on in this complex system.
Yeah, absolutely.
Yeah, interesting.
Yeah.
It was fascinating.
And also recognizing that certain instruments working together can yield a much better result than those instruments working independent. And they could be different detection principles or technologies, but they can help each other generate a better signal. So.
Yeah, good.
So yeah, we talk about asset grade data, and really what that means is like any sort of instrument or sensor that's pulling something from the asset itself. And so that would be your supervisory control and data acquisition, your SCADA, process level intelligence. It could be pressures and temperatures, meteorological data, whatever. Those attributes are ascribed directly to the asset. Asset grade data is extremely important. And I think that a lot of the sensors that are available in the oil field are just maybe not being used or not being considered appropriately to what you're trying to accomplish. And so that's another way of thinking about it is in a given system, what information do I have available to me first and foremost? And then supplementing that, augmenting that with emissions detection equipment or other in order to tell a better story or to get a holistic view of that particular facility.
And I would say too, how easily is it digestible? How easily can you take that in? So like what the audience is seeing on the screen here is a dashboard of one of the Cynthia cameras that we partner with, of an output of a facility. So, is it a written report, or is it, a nice illustration and video and data that you can collect and input to your own system, or, have it put together for you?
Yeah, and there's a little anecdote here. So at the bottom of this, we have community data acquisition and crowdsourcing. And so just this morning, I was on the phone with a maintenance supervisor, oil and gas maintenance supervisor, and he had a unique set of problems that he was trying to overcome. And we got to talking about just like social behavior, human observation, those types of things. And throughout the conversation, I said, what happens? I said, would it be safe to say that a facility, if you're focused on mechanical integrity, and an efficiently operating system is probably going to have lower emissions, okay? What if you thought about outside of that, the lease road itself as an extension, or the county road or the highway as an extension of that facility? Because that is the conduit. That is where you're going through to maintain, to analyze, to measure, for like leak detection, repair programs, and repairing leaks once they're found. The integrity of that road system is probably going to influence the response time to any of that. Okay, call outs, whatever it may be. So through this conversation, was okay. What if there's a way for you to assess the integrity of your road system to see how it compares to the emissions performance at these facilities where it services? Like, for example, if you had some sort of app that said, okay, I've seen chug holes in South Texas that you could hide a minivan in, right? So and 25 mile per hour is speed limit, but anything above 7, your teeth are coming out of your head, you
Yep.
know?
Yep.
And that I have to believe that is a limitation, that is an impedance of efficiently getting to a facility and properly maintain it and do all these different things. So it's that's what I mean sort of there by community data acquisition crowdsourcing is using your human resources and your infrastructure through smartphone applications to generate signals from the environment that could maybe tell something about or supplement the data that you have on the assets. So just it's a little bit like creatively thinking about how we acquire signals from the environment.
Yeah, what can give us new information
Exactly.
that maybe isn't necessarily part of the other sensor network, so to speak,
Right.
but it's sort of being collected by somebody.
It's right. It's right.
Right.
And at low cost.
Yeah.
So
Interesting.
advanced. Yeah, so this is what I mean. So when we say vertically integrated ecosystem, so you have your satellites at the top, you have your aerial drones and your planes, sort of below that. Then you have your asset grade sort of optics and sensors and things on a facility, and then below that you have your kind of first line of defense, which is your handheld OGI cameras, your methane detection instruments. People, obviously, they're constantly looking at things and maintaining things. It kind of goes back to the community crowdsourcing type data philosophy, and then sort of at the ground level, looking for things that have an impact. And as we have here is a plug for our thief hatches. That is a fully composite thief hatch that we developed, and I use it there as an example, is to not just the technology is advancing, but materials are advancing. So that hatch is aerospace grade composite that's non-flammable, and so the idea behind it is to remove corrosion out of the equation, so you get more life out of something. It's sealing better, and so that is a sort of a first line of defense. Is okay, we can find it, we can measure, we can repair it. But then how do we prevent it from occurring again? What's the strategy on reducing this?
That's right.
Long term.
Let's address the root causes. It's good to identify and report and go out there and be reactive, but how do we be proactive and bring solutions to the table to mitigate any of the usual known suspects for those fugitive emissions.
Yeah. It's funny, when I think about the pyramid, I want to hear more about the top of the pyramid, but I'm thinking of some of the roustabouts I used to know in the midstream industry would tell me they knew they had a emissions problem sometimes when the vegetation would die.
Oh yeah,
which goes down to there's this, and this is old. These are old assets, and this was early days of their career. But it really is boots on the ground sometimes to collect that information and really get it. And that's a certain types of signal. Dead plants, right?
Well, they have frac outs on landfills.
Okay.
And that's whenever you see dead vegetation or water seeping out of a landfill, there's probably methane there with it as well. So, I mean, again, that's another observation that can be made, low cost.
Yep.
So.
Yep. But yeah, tell us a little bit about the top of the pyramid as well.
Yeah. So the satellites are really cool.
Yeah.
We made an investment in a satellite company about 18 months ago, and they provide optical payloads for greenhouse gas measurements. And so very, very smart people. They've even isolated the absorbency wave region of plastic. So you could track certain types of plastic in the ocean. The founder of that company was a Hubble fellow, Dr. Rafael Guzman, brilliant man. He was looking at deep space, and he was using different types of filters to classify gases in deep space. And he sort of had the intuition, hey, if I turn this thing around and point it at the Earth, could I classify gases on the Earth? And can I put it in a small optical payload that it can go into low Earth orbit, and then you get the 16 time per day revisitation time. And so you're really getting into frequency and you're getting into the granularity and measurement. And so it was a Spanish company, although it was founded out of the University of Florida, their incubator program. And so we made an investment in them. We've become the North American distributor of these systems for the energy industry. And we just launched our first methane sat last month. So it went up aboard the Transporter 8, Falcon 9 out of Vandenberg. Taylor was there.
Yeah, I was fortunate enough to get to attend. You talk about rockets like when you're a kid, but to see one as a grown man out there, and with the takeoff of the Satlantis JSAT, it was pretty remarkable. So to see that on the SpaceX launch. So yeah.
And and I'm sure you see where it is in the orbit now too.
Oh yes, so I have a monitor on my wall, and I have the satellite tracker on there, and it goes around, and I count how many times it goes over North America, and it's really cool. It can be a distraction though. So.
Oh yeah, for sure, but it's really cool. Yeah. And I see we have a question from the audience here. So we have this thing, that's the satellite that is playing a role in the future of methane monitoring. Where do you see its position in terms of like what is it adding to the system here?
Oh, well, yeah. Question. So in terms of the future, I was introduced to the space industry like 2 years ago, so I'm not an expert in any of this. But what I've seen is, and visiting with the satellite folks, is that there's been a shift. There's been a democratization of space on the private side. So you have so many people sending rockets up very efficiently. By the way, I mean, these SpaceX rockets are hurling out 57 satellites at a time. So there's like this push on the private side. And so what that means is there's going to be more information available to the public around methane leaks and these different things. And so to me, it's going to play a huge role because there's going to be more eyes looking at it than previous. And it's going to be plumbed directly into the social networks on a real-time basis. And so it's going to be difficult to manage, but it also provides a lot of resolution into environmental performance.
Yeah, and I would say from an operator's perspective, it's good for both offense and defense because there's a lot of false claims out there that are made. And so from an operator's perspective, they can go fix any emissions that are happening. But on a defensive measure, they can say, look, we are being a good steward. And actually, this is what is factual, and back their data up to what may be, claimed, to any false claims that may be out there.
Yeah. And so how often does the satellite, how often are you able to pick up data for a given location?
So, I mean, this is complicated.
Yep.
And so they have a mission simulation program that they run. So and it's weird the way that the satellite kind of orbits. You could have a congested group of assets, and you may only be able to visit that once every 30 days, just given the orbit path, right?
Yep.
So it's kind of complicated. There was one customer that we modeled their facilities from East Coast to West Coast, and it was pretty nice, the way that it kind of came down. And that model they had roughly 750 sites, locations in the United States, and they had 2.5 time complete revisitation of all their satellites in a week. So that's good, and then you have enough sort of revisitation to compensate for cloud cover or anything that might be associated, with an orbit. You have enough data there to make sure you're getting good, clear imagery.
And so this is kind of like this is why it's important that there's a democratization, right? I think if I remember correctly, it used to be like $10,000 a kilogram to loft something into space, and now we're talking about
5,000.
Oh, okay. Now we're talking about hundreds.
No. So used to
dollars per kilogram.
50,000 per kilogram. 50,000 per kilogram 15 years ago.
Yep.
Now it's 5.
Okay, so it's a lot cheaper now in that sense. Right. And so what does that enable us to do? It enables us to say, we're not putting 1 up there. We're going to put 100 up there. Yeah. Right. And so that visitation number is for one satellite, right? But when you have
It
a web
is.
of these, suddenly you can cut that divide that number by however many you got up there.
Sure.
That's
And
correct.
you can expand the use to not only emissions, but DOT right-of-ways,
Yes.
and other manners like that. So there
PHMSA
are,
regulations.
Yeah.
that's right.
Those type of things.
And so that's kind of the future here, is where you get that. It's almost real time. Is kind
It
of
is.
where we're going with it. And
90-minute upload, like
Yeah.
on you have 90 minutes
to
upload.
cycle it up and
That's
down
right.
across the satellite itself. Yeah. I'm curious, what's the image resolution? And I guess that has a lot to do with the sensor payload
Sure.
payload itself.
We have a slide in here,
Okay,
I
we can
believe,
get
at the end. I mean,
Yeah.
but just real fast. So it's a 2-channel system. So it has a visible channel and it has an infrared channel. Spatial resolution on the infrared channel is 13 meters on the current one, 2 meters in the Viz.
Yeah.
And like I was telling earlier, though, about how technology is advancing, they're already assembling one right now that has 7-meter resolution in the IR. So, and then as we know, there's satellites up there that have 10 centimeter, 2 centimeter resolution on Viz.
Yeah.
So yeah, that's kind of the range.
Yeah. I'm trying to think. 13 meters. It's probably a little bigger than this room, but it's still
Yeah.
pretty precise in the scheme of things.
Yeah, I mean, I think you can probably get to a point with it where you can distinguish between a compressor blowdown and a tank vent.
Yeah, especially on a site.
Hoping.
Think
I
about,
mean,
yeah.
We receive our first set of imagery next month,
Good.
and we're going to do some controlled releases. So that's
exciting.
no more in a month.
Yeah. But do we want to go to the next slide? I know we
Sure.
spent a bunch of time here.
Yeah.
Sure can.
Yeah, so this is one I harp on like constantly, because compulsory environmental programs have been around forever. They're already a part of your budget. They're already part of your practices and procedures. But looking at these in a different way to leverage more intel out of them. For example, like combustion emissions monitoring. I'm sure, given your background, you're familiar with Fourier transform infrared FTIR spectroscopy, which can literally it can speciate so many different compounds in a combustion stream. So, aside from just the criteria pollutants that you would be required for a compliance program, you can extend that and look at the CO2 and look at the N2O. You could speciate the individual NOx compounds. You can look at methane and all these. I mean, you look at sulfur hexafluoride. I mean, you can look at so many different things in these combustion streams. And then, okay, how do you take that practice to analyze for methane slip, for example? Okay, so now you're taking a input, what's coming into the system, what's the species there, comparing it to your output. What's your reduction efficiency of your catalyst? So there's more intelligence you can pull out of a compulsory emissions test than one might think, and I think people are understand it. But that's just a way of doing something extra with something that you're already doing.
Yeah.
The same thing is like leak detection and repair programs. I mean, there's a ton of intelligence that can be gained from an LDAR program if the data is properly organized and analyzed. And you can look at trends around valve failure. You can look at trends around what are we seeing around these types of pumps or whatever. Using that LDAR data to drive your maintenance and reliability program to where you improve your emissions performance.
Yeah.
Yeah, so as we discussed, the company that we've partnered with is Cynthia Solutions. They're another company out of Spain. They were born out of the University of Madrid. So they have OGI technology, which is OGI is proven, it's been around for a long time. What they're really focused on is not only the filtration and the accuracy of the optics itself, but the neural networks and things that can be built around this, and they call intelligent thermography, of using this communitized fugitive database to improve your detections and the performance of your optics. And we've discussed some of the challenges around that, but I mean it's really sort of the way to look at it. And this camera that they have or that we have displayed here is what's called an AGNI. And what's interesting about this is it's a 2-channel system. It has a CO2 channel and a hydrocarbon channel. And so the use case is like on flares, for example. If you want to understand what your DRE is of your flare, well, this gives you a way to do that stoichiometrically, looking at the different components within the flare itself. And so that's another way for you to model, what is this flare supposed to do? And then, okay, what is it actually doing? And then that helps you sort of backtrack at ways that you maybe can improve the performance of your system.
Interesting. Are you able to infer what's going into the flare through that kind of measurement? Or I guess that's part of the modeling, right?
It is part of the modeling
of the system.
Right.
Yeah.
Like, so you would have your gas input, all of the variables there, and I mean, I think that we could get to a point where that's real time measured as well. I mean, you put some sort of spectrometer on the gas leg. You have a readout, gas chromatograph, whatever, and then it's comparing it to the combustion efficiency that way. I mean, there's so many different ways you can position this.
Yeah, and as far as I know, we have QOGI represented here, and that's something I'm seeing with several customers we're taking on projects for with our LDAR services team. Is they're looking at these more robust plans, and whether that be above and beyond the compliance side of things, and that's to meet all these kind of new demands, requirements, and to meet the new initiatives to monetize their efforts and to keep more product in the pipe. So these QOGI programs are a lot more robust, intense, visiting more assets than are required to do so. But then there's benefit for them on the back end.
Yeah, they're extremely aggressive programs, but that particular program is driven by OGMP 2.0.
That's right.
So tell us a little bit about the benefits, I guess. Let's expand on that.
Well, so the primary difference is with a standard LDAR program, you have some sort of limit. It's a concentration limit, or in the case of OGI, it's like, okay, if it's leaking, you have to do something. It's a leak. Okay.
Fix it.
Tag it, report it.
1 or 0, right?
Yep.
And so, but those don't really quantify. It's more of just there's a leak. It's there.
It used to be binary.
It's
right?
binary.
Now we're talking about a spectrum. Okay.
Now the QOGI programs are, if you find something, first of all, they're redefining. Well, they're redefining what's a leak. Consider a leak. Like if the regulation says 500 ppm methane. In some cases, I've seen them say, okay, we're going anything above background. So if it's 18 ppm, background, anything above 18 ppm, that's a leak. And so there's that. And then they're actually requiring a quantification value. And QOGI means that there are now, these OGI systems now have the ability to quantify to some degree of accuracy, to an acceptable degree of accuracy. And so that's what they're requiring from these and demanding from these, and they're ascribing a mass emissions rate value to each one of these detections, and that's what they're reporting, and it's all for these more global initiatives.
Yeah, and so what I'm hearing is the value, in some ways, is not about just like the individual instance, but this is about actually managing total leaks or minimizing the total leaks, right? Because now it's about volume.
It's also about putting some sort of monetary value
and putting out.
Yeah. I mean, that's.
And so we actually have a question here from the audience about how do we think about things like methane tax or like a carbon credit? How does that play into this discussion?
Sure.
Yeah,
that's a great question.
Well, I mean, from an offset, or if you want to generate some sort of reduction or offset, I mean, this data is really important for that. Again, it goes back to modeling. What's my baseline? What am I seeing? Or am I better or worse? And then capturing any sort of offsets or credits in that process. So there's that part of it. But then if you think about methane tax, we've been involved in some programs where they're looking at methane slip as what's the exposure there. And so again, the only way to do that is to assess your input, assess your output, and see what that difference is, and then you ascribe that on a cost per ton basis, and those kind of things. But what's really driving it is the whole accounting of all this.
That's right.
I
was going to say there's a tertiary benefit as well for RSG, or responsibly sourced gas, right? Where one of our customers partners was able to go out and get a premium, for the sale on their gas for proving this through the different technologies of being a good steward, and that it was, sourced responsibly.
Yeah. So, I mean, that's I think that we are going to be in an environment where carbon credits get bank traded. It's going to be common.
Yeah.
I mean, I think that's ultimately where all this is going. And so the benefit here for a QOGI program is if you're trying to strategize long term, like where does our company need to be in 5 years and 10 years, then you need to kind of know how your facility is performing, at least using the mass rates, converting them to a carbon credit or value. For them to be able to plan and improve, you're going to have to understand what the conditions are, what the baseline is.
Yep.
Right.
No, I like this. So this there are kind of three like value streams, right? There's the value stream around the reduction, and there's a value stream around the responsibly sourced gas. Like allows you to increase the value of this commodity. It's no longer a commodity, right? It actually has a premium value to
Exactly.
it. And then of course you're going to be minimizing your tax stream, which is it's like free money if you save taxes.
Right.
So that those are kind of additive ways on top of just kind of doing the minimum. That's where the value
and
gets
I
accrued,
think,
right?
And I think another avenue to look at here too is thinking creatively about that strategy. Where I'll give you an example. In Florida, I think it's the Citrus Growers Association. I mean, they've been struggling. I mean, they're losing land to plant these citrus trees, and they're looking for money and they're looking for a boost. As it happens, a citrus tree can cycle carbon pretty efficiently. So this was an opportunity for companies that maybe have a significant methane tax exposure or carbon credit tax exposure, and they're looking for carbon sinks and various things. Well, this is a perfect opportunity for you to invest in this co-op and sort of stimulate this other industry over here, and then take credit for the carbon value of that.
Yeah, and going back to, there's no silver bullet. And so as far as like Encino's, value here, we're focusing on QOGI for this slide, which is right. It's the boots on the ground, the QOGI, the people that we've talked about, moving into the continuous monitoring space, and then, the screening mechanism of the satellite, from top down, bottom up, top down. So
kind of interchangeably.
Yeah. No, fantastic. Let's look at the next slide.
Okay. Yeah, we've kind of touched upon this. I mean, using continuous monitoring and detection systems. I mean, we have an OGI appliance, again, talking about the intelligent thermography, where it's using neural networks to improve its algorithms. And it basically uses plume dynamic analysis for visual quantification. The reason why I like OGI is that it provides the boots on the ground with evidence and the ability to respond to something. To me, that if you don't have that visual output, you're chasing ghosts. And so to me, and there's a lot of inefficiencies in that process. So
good.
Okay, and then this is the satellite slide. Yeah. So this is the unit that went up last month, and as we talked about, 13 meter spatial resolution in the shortwave infrared, 2 meter spatial resolution in the visible. So as we talked about how it comes in communications every 90 minutes, it generates near real time data in both the vis and the infrared. And one of the things that I think a lot of satellite data to date has been displayed on a Google Earth type overlay, which, as we know, Google Earth could be 4 years old. I
think I still have a boat in my backyard that's not there. That's no longer there.
So that's why it's important to have a visible channel, because you have an immediate overlay that's captured at the same time, and you can also look at change. But going back to neural networks, we also have the ability to ingest like or create object recognition. So for earlier in the summer, I had one of my children going through Google Earth and cutting out or identifying compressor stations. And I told him I want 1,000 images of these compressor stations. well, what are we going to use this for? Well, I'm creating a neural network.
Yep.
So, I mean, that's the things you can do. So, I mean, where you get to a point maybe in time where it's not only telling you that, okay, there's a methane leak here. Here's a contemporary image or a visible image of that. But, oh, by the way, it's a compressor station or it's a gas plant.
Yep.
And so that's kind of where we want to go with that, to where it's the system is intelligent. And you cut me off. I had a couple more on there.
Did you go for it, man? Roll with it. We got time.
Yeah.
It looks like.
So
Sorry about that. Go ahead.
No.
I like the technical details.
Oh yeah, keep going.
So the system, one of the other things that makes this satellite in particular unique is it has a system of gyros in it. So if you think about it, if it's looking directly down at the Earth, it's a 9-mile swath, but it can tilt 33 degrees and get it 250 miles, and then all of the detections are geocompensated.
Yeah, interesting.
So it has what's called an agility feature, pitch and yaw, backscan. And that's what makes it a really good tool, especially if you're trying to track like pipelines or coastlines, nonlinear type areas, infrastructure.
That was like a magic feature 10 or 15 years ago on these microsats.
Yes,
so that's a lot of capability now.
It
These
is
small platforms. Yeah,
it is.
Interesting. Cool. And did you have more you wanted to
No,
speak about?
I mean, he cut me off.
I
No
think
problem.
one of the things that's also interesting about this. Well, I had a thought, and I'm trying to remember what it was, because I was thinking about like the swath. How do you correct for the angle? Is that
Oh, please don't ask
okay?
me
Okay,
that
fine.
question.
That's math.
The azimuth and the asymptote and
azimuth of
angle of the
decline.
dangle.
Yeah, angle of the dangle. That's the right word.
I have no idea.
Well, let's talk about how people can get in touch with you guys then. Yeah.
Yeah, absolutely. I mean, this is a contact us page, so please follow us on LinkedIn and our website and our numbers. So appreciate your time here and welcome any questions that the audience may have.
Yeah, and while we wait for more questions to come in, I remember what I was thinking about now. We didn't really talk about neural networks and kind of image recognition. We didn't use the AI word, and we'll leave it over there if we don't want to. But we're kind of in this golden era of the image recognition. Maybe in the last 3 to 4 years. But
no doubt.
It's funny. You made a compression recognition algorithm. I made a cat recognition algorithm like a few months ago, because I was curious about it. But it's amazing how robust and easy it is in some ways if you train it with the right data set. And I know it's something we were talking about at I think Fuse last year. It's just how that technology really has improved and allows us to do this matching of data in a way that was just manual before.
Right.
That's right.
It's scary.
Yeah.
I mean, but it's also useful.
Yeah.
So.
And it's impressive. Like you only got to train the computer once instead of having a person go through every time.
Yeah.
So that's really going to change things for our ability to really rapidly respond, because now this is what this emission is tied to, and allows us to use.
And that system's constantly improving.
Yeah.
That's right.
So it's evolving.
And when you get it, and now you don't have to go in and wait for it to get loaded into a GIS database. You can see it when a new system gets installed. Right?
Well, the next satellite we're launching in December is called Skynet.
That's exactly what we want to tell people.
It's not.
Oh man. So one of the questions we have here is within a customer organization, what role benefits most from this kind of service?
What role benefits? I guess it would be, if you're looking at the all-in integrated solution, it would be the sustainability, the corporate sustainability folks who are looking at, kind of the big picture of, what their company's objectives are, and what, they're trying to do to not only be a good steward environmentally, but then also, keep their product in the pipe and hold on to their commodity there. So that, and then, ground-based, it's all the folks that are spread out across, not only the globe, but here locally, at the lower 48, at all the, the facilities, the production sites and facilities where, the rubber meets the road, so to speak.
Yeah.
It impacts all
It really does.
A lot of elements of a company. I mean, you have engineering, they're looking at different ways of improving these facilities. So they're gathering intel from the sustainability groups and the environmental folks, kind of bringing them into the conversations. It affects the sustainability groups for strategic initiatives of how do they advance these programs to demonstrate good stewardship. But ultimately, it impacts the people on the ground who are having to deal with it and fix it and maintain sensors and nodes and all of the stuff that goes on.
That's a good point.
Yeah.
And I think I'll add to that. And I think that's kind of a unique perspective we have at Encino is we are, oilfield service company by trade, environmental oilfield service company. But with our partnership with these high technologies, like we've, kind of demonstrated here today, it's a unique perspective because there's a lot of high tech companies and there's a lot of service companies.
That's right.
There's only a handful, if a few, that have both. And so you've got that, if you've been in the field, versus that, but you need that expertise in the PhDs who are creating, all these neural networks and technology that we said. But, from a service perspective, the oil field's always been known, right? It's 24/7.
Yep.
Yeah.
Yep.
So
gotta be on call.
Yeah. So.
Yeah. No, and I think that's an important distinction. This is about service and servicing the customer where they need it to be serviced.
That's right. And what's important to them, right?
Yeah.
Because a lot of times you could take the approach of what you think is important, but what's important to the client. And if you've been there, done that, and you're listening and talking to them and communicating, to hear that, then.
Well, and each company has its slightly different personality.
Yeah.
And
True.
It is. You have to be able to adapt to their goals and objectives.
That's right.
So the goals and objectives of a super major is not going to be the same as maybe a small private equity backed company, but they're still having to demonstrate the same thing to their investors.
And one of the strengths I'm hearing with Encino is, you're an oilfield services company. I mean, you serve kind of the full stack within the operator's business, right? And data means different things to different people, right? Data for the ESG officer is different from someone who's boots on the ground. And I was appreciating your dashboard earlier because I'm at the point in my life where I like to see the dashboards. I don't want to see numbers anymore. I need to see trends.
Excel spreadsheets of just data.
What does this mean on a month-to-month basis?
Sure.
And because that's what I'm looking for. But when you're in engineering, it's like, what's the baseline? What am I working against? I want to see what's really going on a time series basis for these systems. And so having that kind of understanding of the different levels that an operator operates at is a unique value proposition and being able to really listen to the different aspects of a business.
And it's important too, like we talked about earlier. You can have a great instrument manufacturer, great technology, and you can have a use case, but there may not be what this person who built the instrument thinks is valuable may not be actually valuable to the person using it. So there's that user experience that's extremely important, and that's why the investments that's where we were strong. We felt strongly about making investments in these to where we have sort of a seat at the table, and we can take back from the field to our partners what the customer wants, and then we can make those changes in there more efficiently than just being, this is an instrument provider, this is the user, figure it out.
That's right.
Let's see. But we have a question from the audience. Do you have a view on EPA's regulation for CH4? Is this trimming or timing? I'm going to go with timing. No, methane trimming. Let's go with that.
Yeah.
Methane trimming.
Yeah.
I guess in the context of reduction, or I'm not.
I guess it's reduction. Yeah.
Okay. Well, again, I think that you could have any sort of, you can put any number you want out there, but at the end of the day, what's reality? Is that number realistic? My concern with EPA data, or in those who are kind of crafting regulations around it, one of my concerns has always been again, going back to the factors that have been used to represent these facilities in terms of their climate performance over the past 10 years, how realistic are they? And do we have enough information now or from sensors, networks, for measurement to maybe rethink those values? So, the thing is what are we reducing from? What's the level that we're reducing from, and what's the confidence in this data that we have? To me, the only way to address that efficiently is to model and measure. Model and measure, and do it in an auditable fashion, or make it to where it's fully transparent and audible, to where it's like, look, this is what the emissions are. This is what is realistic. I don't know if I can reduce beyond this, just because the conservation mass prevents me from doing it. So,
I remember from being more on the engine side of things, I found regulators to be very, very curious and interested in, where do we want to go, but also what's actually achievable that industry can meet realistically, right? Because you can't come out with a regulation that's impossible to serve for physical reasons, but also just from a CapEx perspective, right? You can't ask industry to change too quickly in a way that would put them out of business or cause them to be uncompetitive. And I'm always amazed how much organizations like the EPA have their ear to the ground on what does technology let us do, right? Where's the future of this going to go, so that they can craft the regulation the right way.
I think that the government might be trying to address that a little bit through the IRA, right? So it's like, we're gonna impose these regulations on you, and it's gonna be onerous, but here's some money for climate tech.
Here's the resources to let you do it,
right? And then there's all these partnerships with universities and things like that.
That's right.
I think, but it's frustrating, but I think that there's still opportunity in it. It just being able to think about what resources are available to you to address these things.
Yeah. Good. Do you have anything to add? Sorry.
No.
Yeah. Is there anything else you guys want to touch on at the moment?
No, this is. Are we running short of time or long?
I think we're right there.
That's where I'm asking. I got distracted for a second.
Okay.
Yeah.
Okay.
Yeah.
I have another oil field joke.
Oh, well, tell it. Yeah.
All right. What has 4 legs and goes woof?
Not a dog.
A rig on fire.
Very good.
I think we're trying not to have those anymore.
Yeah.
So,
Call back.
Did you do service? So obviously, as a services company, I assume you go out to the field quite often.
Oh yes. Yeah. The mobile testing laboratories. They're do batch testing of units. They just roam around the field. They stay in constant motion. LDAR crews they stay pretty loaded up as well. We have presence in. We have an office in Casper, Pennsylvania, obviously Texas, New Mexico. We work, so they're scattered. It's interesting because these are environmental services on a oil field pace. So we very much follow the cadence of the oil field. With some of these other services, obviously, satellite's an entirely different animal. And then we did several years ago develop a system of deploying these cameras using a mobile system. So kind of meeting the needs for EMP, where everything is sort of like temporary and you're in and out, transient. We developed that in mind. So our camera trailers will just move from site to site as well. But they typically stay out 30 to 60 to 90 days, and sometimes up to a year. So.
And so you have operations in the major fields. I'm curious, just for the both of you, what's the most remote place you all have been as individuals?
Remote place?
In the oil field, yeah.
So remote, being away from civilization, I would say deep water.
Yeah, okay.
That's pretty out there,
that's
right?
pretty out there.
That's pretty remote.
I've never made it
early on in my career. It was in deep water
How
operations.
far is that off from land?
I think it's like 90 miles.
Far enough you can't swim.
Oh, okay.
5,000 feet of water.
I was on a platform that was 160 miles out.
Okay.
I guess that's
Okay.
pretty. Is
Yeah,
that
that's,
considered
that's
remote?
pretty far.
Yeah.
Yeah.
Okay.
No,
Those are-
I've never made it further than like the Bakken. So.
Yeah.
Oh, I've been to Canada,
Yeah.
Edmonton area.
Edmonton still has people. I promise.
Mhm.
No, good. Well, glad to have you guys here. I guess we'll throw up the slide again for how to get in contact.
Okay.
What's the best way for folks to reach you? LinkedIn, obviously the website.
To reach us, the website.
Yeah.
Yeah,
Yeah.
our website.
Contact us link at the website. And then to follow all the good things we're doing, follow us on LinkedIn.
Yeah.
That'd be great.
Good. Well, thank you all for being here. I learned a lot. I'm really excited
Great.
about what the future holds and the value we're going to create.
Yeah. Well, no, thank you. Thank
Yeah.
Digital Wildcatters and
Yeah, we appreciate it.
for affording us the opportunity to meet here today.
Yeah.
Yep, we enjoyed
Yeah.
it.
All right.